Here is the example information they provide for you. Okay, basically what they're showing you is these different symbols represent different parts of the complex number. Okay? If you see this jagged straight line, this represents the real portion. If you see this coiled line, it represents a positive imaginary number. Okay, so you're going to add an imaginary number when you see that, and then when you see this break, you're going to subtract or use a negative imaginary number. Okay, so when you look at these problems, so let's say we take this example A. In looking at this problem, as we go through the circuit, so let's just start along here. As we go through, when we come to this jagged straight lines, how do we need to rewrite that? It's the real portion, so it's going to be, again, it's whatever number's here, right? So it's going to be 2. Okay, and then as we move through, we get to a coiled portion with a 5. The coiled portion is going to give us a positive 5i. And then as we work down through, we come to this break, a 7. And so what's that going to represent? Minus 7i. And so when you combine this whole thing, you get a total of 2 minus 2i. And so that's how you would create your complete complex number. Does that make sense how it works that way? Okay. All right, now when you look at question number 96, it gives you a formula to use for impedance, which is it's the Z1 times Z2 all over Z1 plus Z2. You're just going to take each of those little circuits individually, the Z1 and the Z2 portion of it, and you're going to just plot those values into the fraction, the product and quotient, and you're going to simplify that number.